Hey guys, Professor Benson here. Just wanting to show you a little bit about. Sorry, I've changed. I felt like a lot of people were struggling with the Chapter 7 and Chapter 8 quiz, so I hadn't done a good job of explaining it. And so I've put together some additional materials that I want to walk you through. And so I have pushed back the videos, the quizzes to be due Wednesday evening. I moved back the central limit theorem, so the spreadsheet 5 to be due tomorrow evening. I just want to show you the resources and stuff, and I've recorded a couple videos here. So I just want to make everybody aware of it. So I have put it, I'm here in modules. Okay, and I'm down here with the week 3, what to know for week 3. I just decided to put all the resources here as opposed to creating a new one. And so I'm just going to show you this, that I've added some practice questions with Z-scores and the solutions. I have the solutions both as so this is what the solutions in Word look like, where I've actually written it out here and then the formulas. If you'd rather see it as this, where which is what you will see from the video. I actually fill this out in the video so that you can see, me filling this in, coloring all these things in. Okay, so these are from Chapter 7. This is more how to do Z-scores and percentages. These are the Z-scores you would get with the population, and I'll talk about that in just 1 second. But I just want to show you that there is those are the questions. You can choose either of these solutions, and then that there is a YouTube video. I'll go ahead and bring it over here of me. Here it is of me walking through it. Okay, and this one is like I put it down, I put the camera up, and in fact it looked pretty hillbilly the way I rigged it up. But you'll be looking essentially over my shoulder as I solve it. Okay, then the next, so I recommend you do that first, and then what you do is you go do the spreadsheet exercise it's called S5. Okay, so if I go back here, it is, I'll just go back one, this S5 sampling distribution. Okay, that one looks like this. Now I'm sort of in there twice, but what we're going to be doing is the sampling. What the sampling distribution means is there's this true population, and if I take repeated samples and then we're to plot the means of each of those samples, that's essentially what we're going to be doing in Chapter 7. And then this allows us to make inferences from that. This is how we calculate those inferences that we make from the sample back to the population. Okay, now I'm just going to show you here these slides. I just realized I did not, and I'll go ahead and hide myself. These slides I realized I did not put in, so I'm going to need to upload those. But I'm just going to show here the ones that I'm doing in the where I'm calculating the Z-scores in that Word document I showed you. I'm using this one over here where I'm doing samples from, or not samples, I'm just saying what percentage in the population are below 75 inches. So for example, a sample problem like this one would say the cholesterol levels in women are normally distributed with a mean of 178.1 and a standard deviation of 40.7. So what percentage of women have a cholesterol level greater than 260, a value which is considered moderately high? And it turns out we actually care about the bad cholesterol more than the total. This is called the serum cholesterol, which is how much is in this is like milliliters per deciliter of blood if you care. And so this is how you calculate it, and we do several of those in the Word document that I was just showing you. And then if you wanted to do it in Excel, and there is an Excel spreadsheet that allows you to calculate that. Okay, and so, but if you wanted to do it straight in Excel and not even calculate that this is 2.102 standard deviations from the mean, you could actually sit and do it and just plug in what's the value I care about, what is the mean of the population, what is the standard deviation of the population. True just means give me the cumulative probability up till that, And so 97.8% of women have cholesterol levels below 260. And so 100% minus 97.8% is how I get 2.1% have cholesterol above 260. Okay? Because it has to add up to 1. More of the problems in Chapter 7 are going to be like this, but say, look, we've got the same population, but now I'm going to take a sample of 64, and I want to find what's the probability that the mean of my sample is less than 180. And so the point is that the sampling distribution, so if I have up here, this blue guy is my population, and these are my repeated samples. You'll notice this guy is there's much less spread in there than in the underlying population, and that's because if I take a sample, I'm going to get some guys from this side of the distribution that have high cholesterol, and some side that are low, and they're going to balance each other out on average. And so the sampling distribution is always going to be skinnier than this one, and the larger the sample, the skinnier it gets. Okay, and that's what Spreadsheet 5 does. You're actually going to calculate that. You're going to see that, and it the bigger the sample, the skinnier this is going to get. But it doesn't. If you double the sample, it doesn't get half the size. And that's because in this denominator isn't n; it's the square root of n. So if I want to cut it in half, what I end up having to do is, instead of going from 25, which is the square root of 25 is 5, I have to go up to 100 because the square root of 100 is 10. So that's the problem. Okay. So down here, when you say, okay, what's the probability if I take a sample of 64 women that the mean that I get in that sample is less than 140? Which is going to be close to this population of mean of 178.1. Sorry, I'm looking down because it's down here on my screen. Okay, and so I could say, well, that's 3.73 standard deviations above the mean. Okay, and if just remember as I go down, so this is the mean of the population and its standard deviation. So it's mu and sigma. In expectation, so these should line up, but in expectation, they'll have the same mean. We call the sample mean x bar, and we call this one mu. But its standard deviation is going to be smaller. It's going to be this same population standard deviation divided by the square root of n. Okay, and so when you use the formula, instead of putting in 40.7, the population standard deviation, you to put in 40.7 divided by the square root of 64. What I put up there. So 40.7 divided by 8. And it will give you that. You'll get the same answer on both of these, that 64.54% of the samples with size 64 will have a mean less than 180. Okay? And what that means is you will get questions in the Chapter 7 quiz that will be similar. They'll be similar to these. Okay. The final thing I've put there is, if I go back here. Sorry. So let me come back one thing. This gives you. So this is already out there. I put this up over the weekend on Friday or Saturday. So the spreadsheet is here. And the YouTube video on how to do it is up here. That's out there. You can watch it. It is long, so that you're watching me create it, and that takes me 43 minutes there. So I expect if you have to stop and go back or anything, it'll probably take you an hour and 15 minutes, just depending on how familiar you are, say, with VLOOKUP. A couple things like that. Okay? So we'll end up going back. And also with this one on the ZScore, once you've done a few of these, you don't need to keep going. But I need to show you, how many are. This is an actual. You can go look at this article here because the Air Force just did change their height requirements. Because 40.5% of women were considered too short. They're less than 5'4", and the Air Force said we have to be 5'4" to be a pilot, and so they were excluding 40% of women. And then this one says, okay, well, how do I find between? Because you'll get lots of questions between, sorry, I'm going to pause to get a drink here. So I just paused to get a drink of water. I may have to stop again. But if you need between two numbers, then what you end up doing is, so this says what percentage of women are between 5'2", so 62 inches and 66 inches, if the population mean is 64.6 with a standard deviation at 2.5. Okay, and so then what you do is you say, okay, well, I first calculate the probability up here to 66. Okay, and then down here, I'm at what's the probability up to 62, and then I just subtract the two. So there's 71.23% below 66 inches. There's 14.92% below 62 inches, and if I subtract those, you get 56.31, and that's the difference. And that's whenever it's between the two, that's what you have to do. Okay, but I want to show you that with the Z-score. The only thing that changes from this to most of the questions in Chapter 7 is that when we're dealing with, and maybe I'll make this bigger, if we are dealing with not the population, so this is what we're doing with the population, if now, in both cases, I'm taking your distance, the particular value minus the population mean, and I'm dividing it by some standard deviation. Over here with the true population, I'm dividing it by sigma, the true population standard deviation, if we know that. Usually we won't. If I'm doing now with a sample, the standard deviation, over here it was just sigma, here it's sigma divided by square root of n. And we call that the standard error because it's the standard deviation of the repeated, this is the mean of the sample means and this is the standard deviation of the sample means. And so you end up doing it like here. So so I've given you some problems. So if we look here, now I have Chapter 7 practice problems. These ones are around the sample means and sample distributions. I'm going to give you, I'm almost done, but I've got one on proportions and the finite correction to show you. But these are the questions here with the, I can bring myself back out. These are the questions with the sample mean and standard deviation. So I've given some true false ones that are similar to what you would get in the quiz, right? I consider selection bias and this non-response bias to be very similar. But then you'll get, but then this is when questions 8 and 9. 9 is going to give you a whole bunch of questions about. And so you'll just recall that the standard error here is 9, so sigma divided by square root of n. And then this one is suppose electricians earn $54,000 a year. That's the mean of the population, and the population has a standard deviation of 12,000. And if you in fact knew that, you don't need to take a sample because you already know the answer. But it says, look, if you take a sample of 4. What is the standard deviation for the sampling distribution of the sample mean? Then I say, what's the probability that if you pick 4, that the mean of that sample of 4 is greater than 60,000, even though in the population, so it's essentially, what's the probability of getting a sample over 60,000 when the true population mean is 54,000? Okay, so you'll notice here, I'm taking the 12,000 population standard deviation and dividing by the square root of 4 because my sample size n equals 4 in this case. And then it says, okay, what's the probability of, so this one was what, greater than 60? This one was less than 50. If I take a, same information, I grab 4, what's the probability the sample mean is less than 50? And then I do, hey, what is it between 50 and 60? And this is exactly the same. Right, I have to calculate what's the probability of getting less than 60. If I pick out a sample of 4, what's the probability? If I picked out 100 samples, what percentage of those are going to have a mean less than 60,000? And then this one is, if I do the same thing, what percentage are going to have a sample mean of less than 50? And then I subtract the two to get what's this part in the middle, which is 58.88%. Okay. So, what else on this? There was one more thing. if I go back here. Oh, yes, yes, yes. Okay, so in this video here, you'll see at the beginning some formulas for the normal distribution. Okay, and those formulas are in this normal distribution spreadsheet under a page called formulas. Okay, so I show them at the beginning. I printed them out and put them under because this one I set up with a camera facing down. I took my webcam here and faced it down so that you could see me working this stuff out. But that is what that is. Hopefully this helps. This is a long video, but hopefully you can watch it at double speed, and I will talk with you soon. Thanks.